I'm going to power through these last 6 problems. Starting with 11, so rewrite using rational exponents. Rational exponents are just fraction exponents. So I always write that fractional next to it. So to write these as a fraction, you need to have, just like in these last problems, you need to have your power and your index. So the power goes on the top, and then the index is in the bottom of your fraction. So I like to write all of these with a power. Like this is 3 to the first power, so it's 3 to the 1 over 5, x to the 2 over 5, and y to the 3 over 5. If any of these fractions simplify, you would want to rewrite that in simplified form. Okay, this next one is 16 to the first. So that's 16 to the 1 over 4 and x to the 7 over 4. We do know the 4th root of 16 is a 2. We did that one earlier, so you guys can simplify that to a 2. And then x to the 7th fourths, we can't do anything more with that one. If it was like an 8/4, you would want to just write that as x squared. Okay, these say simplify, so on number 13, I'm going to follow exponent rules, which says when you have a power raised to another power, you're going to multiply your exponents. If you forget your exponent rules, you can always try to do one that's like a simpler problem. I usually will pick something like x squared cubed. And if I'm trying to remember, do I multiply those or add? Just write it out. Write out what does that mean. When you have x squared cubed, that means you write out x squared 3 times. And then each of the x squareds is like 2. So you can see that we have 6 of them, which means I take these exponents right here. Oh no, what just happened? There we go. We just take these exponents here and you multiply them. So that's what I'm going to do on number 13. I'm going to multiply, so I'll have 36. And then when you multiply fractions, you just go across the numerator and denominator. So that's -3 over 6, which simplifies to -1/2. And I know a negative power, I move to the denominator, and I make it a positive power. And I know that a 1/2 power is a square root, so my answer is 1 over 6. On 14, change colors here. On number 14, we don't want to take care of the squared before we do the subtraction. So we have to follow order of operations. And in the order of operations, we have to do everything in the parentheses first. So when I look in here, is there any simplifying I can do? Yes. We know 25 to the 1/2 power means the square root of 25. And then we know 4 to the -1/2 is 1 over the square root of 4. And I'm just carrying that squared down to the next line. So then you're going to start evaluating. Square root of 25 is 5. 1 over the square root of 4 is 1 over 2. What is 5 minus 1/2? It's 4 1/2. 4 1/2 is the same thing. If you take 4 times 2, you get 8 plus 1 is 9 over 2, 9 halves. Or you can think of 5 like 10 halves minus 1/2 is 9 halves. And then if you square that, you'll square the numerator, square the denominator, and you get 81/4. I feel like somebody would have had a question on that one if we were actually in class. Okay, 15, we're combining these. We've got, I know that's multiplication, so that's y to the negative 8th power times y to the 6th power. And then with something like that, again, I make up a problem, and that tells me what the rule is. So this would be like 2 x's, this would be 3, which is x to the 5th. So when you have like bases and they each have their own exponent on them, you would add your exponents here. So I'm going to add these together and I get y to the negative 8 plus 6. That's y to the negative 2nd. That's 1 over y squared. And then last, I'm over 5 minutes already. Okay, last one. I'm going to look in the innermost parentheses, 2a. There's nothing to do there. Can I raise that to the 4th power? Yes, that would be 2 to the 4th and a to the 4th. And then I'm going to take that and raise it to the negative 2nd power, which means I multiply these powers and I get 2 to the negative 8th times a to the negative 8th. And then I'm going to multiply that by 2 right here, and then a to the negative 2nd. That's a 2 to the 1st power. So now these are like bases. They both have 2's. So these exponents can be added together. So this is 2 to the negative 7th power. If you take 2 to the negative 8th and 2 to the positive 1st, and 2 to the negative 7th. And then these two would be a to the negative 8 plus negative 2, which is 2 to the negative 7, and a to the negative 10th. And then to rewrite that in simplified form, when you have negative powers, you just move them to the denominator. So 1 over 2 to the 7th, a to the 10th. You know 2 to the 7th power? I don't, but we can figure it out. So I know from earlier 2 to the 4th power was 16. 2 to the 5th power then has to be 32. 2 to the 6th power, you multiply by 2 again, you get 64. And so 2 to the 7th power is 128. So this is 1 over 128 a to the 10th. The end.